In this problem, we want to take the integral of sine to the power of 4 of theta d theta from 0 to pi over 4. Whenever we have a function with sine and cos, combination of these two, sine times cos, something like that, and all the powers of sine and cosine are even numbers, like this case, we need to use two trig identities. First one is sine squared of theta is equal to 1 minus cos of 2 theta over 2. And the other one is cos squared of theta is equal to 1 plus cosine of 2 theta over 2. Just pay attention that these two equations are very similar, just the sign is different. And these are referred to as half angle identity. Okay, so what we're gonna do here is rewrite sine to the power of 4 theta as sine squared of theta all squared, because we know that when we write it in this way, these numbers get multiplied by each other. So we have 2 times 2, which gives us the same 4. But what the reason that we do this, we know that we can rewrite this sine square of theta with this identity. We can replace that. So basically we can write that as integral of that part squared d theta, which is 1 minus cosine of 2 theta over 2. And now here, because we have a numerator and a denominator, all of them to the power of 2, we can raise each of them separately to the power of 2. So we can write it as 1 minus cosine of 2 theta squared over the 2 squared, which is simply 4. Now here I can take out the 4, basically 2 squared. And because it's in the denominator, I'm basically taking out 1 over 4. So I have 1 over 4 integral of 1 minus cosine squared of 2 theta all, cos of 2 theta all squared. So just this part. And now we can simply expand this segment. So simply we have 1 minus cos of 2 theta times another 1 minus cos of 2 theta, which is going to be squared. So I can write it 1 over 4, which is what we have here. So integral of the expanded version would be 1 minus 2 cosine of 2 theta. And let me just move this a little bit to the left. Plus cosine squared of 2 theta d theta. Now, when we expand this expression here, you would get these three terms: 1 minus 2 cos 2 theta plus cos squared of 2 theta. Which, because there's summation and subtraction and this summation in integral, we can separate that. We can write that as 3 different integrals. So what we have is a quarter, which is at the front of everything. The first integral, which is integral of 1 d theta, minus 2 cosine of 2 theta, the integral of that, d theta, plus the last part again, cos squared of 2 theta. We take the integral of these again separately. And don't forget that I didn't write the bounds yet. I mean, I will write it at the end. I mean, instead of just for sake of time, all of them have the same bound, 0 to pi over 4. Now, the first integral, 1 d theta, the integral of 1 would be basically the same variable that we have is theta. Minus the integral of this, I mean, the 2 is a constant, we can take it out. The integral of cos of 2 theta, if you want, you can use a u substitution, or if you already know it, it would be sine of 2 theta over 2. Don't forget that we have a 2 at the front, so we keep it here. So let me just make it this way. Okay, minus 2 times sine of 2 theta over 2, and plus sine, and the last integral, the integral of cosine squared of 2 theta d theta. Unfortunately, I don't know the integral of that right away, but what we know is because it's a cosine squared, we can simply use identities that we have here. So I will use these identities this time. So let's just take this integral separately. Okay. So that integral is integral of cosine squared of 2 theta d theta. The identity that I'm gonna use is cosine squared of theta is equal to 1 plus cosine of 2 theta over 2. So here what we have is cosine squared of 2 theta. So not just theta, it's 2 theta. So when I'm gonna replace it with this identity, it would be 1 plus cosine of 2 theta, or basically 4 theta. It's whatever we have here, it's twice of that here. So in this case, we have 2 theta. So here we have 4 theta. All of that over 2 d theta. I can take out these two out. So I can write it as 1 over 2 integral of 1 plus cosine of 4 theta. Okay, just write it better here. 4 theta d theta. And again, we have two parts, the integral of 1 and the integral of cosine of 4 theta. So the integral of 1 would be, let me just write the 1/2. The integral of 1 would be just theta, and the integral of cosine of 4 theta would be sine of 4 theta over. Again, if you don't know it right away, there is no problem. You simply do the u substitution, and this would be your u. Now we have it half times that, and this is only this part. And we did it here. Now if I write the whole answer again, so we had got the equal sign here. So we had a quarter times theta. I'm just writing this term, minus 2 sine 2 theta over 2, 2 sine of 2 theta over 2, plus the last integral, which we evaluated that here. So I write it as is 1/2 theta plus sine of 4 theta over 4. And we don't forget the bounds are same 0 to pi over 4. So at the end, we need to kind of replace them by 0 and pi over 4. So first, let's plug in the upper bound. Or before that, let's just simplify it. So cancel these two with these two. And basically, that's all we can do. Let's plug in pi over 4. If I plug in pi over 4, let's see what we get. We get a quarter times pi over 4 minus sine of 2 times pi over 4 plus, just multiply these two. It's half times pi over 4 plus, again, multiplying these by this term, it gives us sine of 4 times pi over 4, all of that over 8, 1, 4, 8. So this is when we plug in the upper bound. Let me just write it a little better. Okay. Minus when we plug in the lower bound 0. So it would be again a quarter at the front. So we have 0 minus sine of 2 times 0 over 2, kind of we simplified that, plus a half times 0 plus sine of 4 times 0 over 4. So this is when we plug in the lower bound. Okay. The second part here, when we plug in the lower bound 0, this is 0, sine of 2 times 0 is 0, sine of 0 is 0, 0, sine of 4 times 0, it's again 0. So this part is entirely 0. Let's just analyze this part. Let's just evaluate that. So it's a quarter multiplied by pi over 4, which is a number, minus sine of 2 times pi over 4. Okay. We can simplify the 2 and 4, so it's pi over 2 overall. Sine of pi over 2, we should know that it is just 1 plus half times pi over 4, which is just pi over 8, plus this term. Sine of 4 times pi over 4. 4 times pi over 4, we can simply cancel these two, which is just sine of pi. And again, we need to know that sine of pi is 0. So we have 0 over 8, which is just 0. I didn't have to write it. Now what we get is quarter times pi over 4 minus 1 plus pi over 8. Which if I just get whatever I have in the bracket, I just have a common denominator there. The common denominator would be just 8. And the numerators would be, it's 4 to 8, okay, times 2, so it's 2 pi. Here I have 1, so it would be minus 8. And here it's just already 8, so it's just plus pi in the numerator. So overall, we get 32 as a denominator, 4 times 8. And the numerator is what we have here. Don't forget 2 pi plus pi is simply 3 pi minus these 8 that we have. So this would be the final answer to this integral. And all we used is these two identities.